eventually it's going to push so hard. G'day everyone, welcome to another Science Lab ANU. My name's Dr. Graham Walker. I'm from the Centre for the Public Awareness of Science. In fact, we're right outside our beautiful building. It's a lovely day here on campus, nice and warm. Great day to do something nice and cold. We're going to have a look at some liquid nitrogen. And what we've got here is very, very cold. It's about minus 196 degrees. So you might have had a wart burn off at the doctor, and we use liquid nitrogen for all kinds of things around the campus, cooling big machines, cooling down experiments, preserving samples, because it's very, very cold. It's useful for lots of different things. But we're going to have a look at a different property of liquid nitrogen today. Rather than the point at which it's a liquid, minus 196 degrees, we're going to look at the point where that liquid changes into a gas. And when a liquid changes into a gas, something quite interesting happens to it. Let's pour a bit of our nitrogen out. I've got a little science jar here with a balloon attached. We're going to pop the liquid in. As soon as I pour it out, you can see that fog coming off. The cold nitrogen's making the air condense, but something else that you might be able to see as we come a bit closer is that that nitrogen is bubbling. The nitrogen is actually boiling. It's changing from a liquid into a gas. Now, we can't see that gas so easily because it's see-through. In fact, most of the air is made of nitrogen gas. If we want to see our nitrogen gas, we've got our liquid, now we've got our gas. Now we can see that liquid turning into the gas, and off it goes, okay? It gets hundreds of times bigger as all those molecules, when they're a liquid, all close together. As a gas, they spread out, they take up enough space. Eventually, they blow up the balloon. Now, the question is, what if we use something a little bit stronger than a balloon? What I've got here, this innocent little soft drink bottle, is actually incredibly strong. A soft drink bottle has to hold pressure because of all those bubbles that get squashed in to make it fizzy. What we're going to do is, rather than the nitrogen in the balloon, we're actually going to put it in a bottle and we're going to see if it pops. Now, when it pops, it's a pretty good pop. So what we've got here is a specially designed explosion-proof rubbish bin. And if that wasn't exciting enough, what we've got here is a whole team of highly trained science stunt teddies. Now, these stunt teddies are put through intensive short courses here at the ANU. They do like crash landing, extreme G-forces, descending from trees, remote area training. These teddies are up for it, ladies and gentlemen. What we're going to do, put the nitrogen in the bottle, put the bottle in the explosion-proof rubbish bin, put the teddies in on top, and do a little experiment I like to call the liquid nitrogen teddy bear volcano. So let's try that out. So we've got our teddies, we've got our liquid nitrogen. Pop those gloves on. We're going to get a little bit of more nitrogen out. Now, we don't need much nitrogen because a little bit of liquid makes a lot of gas. We're going to need the pressure to build up in that bottle until it's about 5 times as high as the pressure in a car tire. That's about the pressure it's going to pop, up at around 150 psi. Now, I can feel you through the screen going, Graham, what about the teddies? What about the teddies? Ladies and gentlemen, as I said, these teddies have the highest level of stunt teddy training. And I promise you, ladies and gentlemen, please don't worry about the teddies. I promise you they can bear it. Okay, all right. So let's try this out. Okay, so we're going to take that lid off. We're going to pop that nitrogen in. The nitrogen has already started boiling, changing from a liquid into a gas. At the moment, that gas is escaping out the top of the bottle, but pretty soon, we're going to pop the lid on. Then that gas is going to be trapped inside, and it's going to start pushing on the inside of the bottle. All right, everyone ready? Okay, so on goes the lid. Pressure's building up. All right, you can go out, teddies. All right, okay, all right, all right. Now, inside, the pressure is getting higher and higher and higher. You can imagine that gas is pushing on the inside of the bottle, pushing, pushing, pushing. Eventually, it's going to push so hard. off it goes. So once that pressure builds up, our nitrogen literally, let's try and find the bottle. Oh, we've got some of the bottle in there. We've got, we've got more of the bottle in there. Wow, it's been a really good one. And here's what's left of that bottle, okay? So our liquid nitrogen, boiling, changing state, building up that pressure. Once that pressure gets too high, the force on the inside of the bottle, just too much. And you saw what happened. See you for the next lab.